now we'll start the topic moment of inertia matrix. So we know that the angular momentum of a system is defined as I omega, or mr cross omega cross r. So here let us consider a body with I particles. Then if each particle is located at a position vector of Ri with a mass mi, then the angular momentum of the entire system is sigma I to m MIRI cross omega into Ri, where omega is the angular momentum with which the body is rotating. So Ri, of course, these are all vectors, so they will have three-dimensional components. So Ri will be xi, yi, zi, and omega is equal to omega z, omega y, omega z, omega x, omega y, omega z. And now, to calculate the angular momentum of the entire system, we'll go through a step-by-step process. First step, what you do is you calculate omega cross Ri. So if it's doing a cross product, let's say it is equal to Ia plus Jb plus Kc, where A, B, C are the respective cross product components as shown. So after you calculate this step, next step will be crossing this with Ri cross omega cross Ri. So when you know that Ri is xi, yi, zi, and you cross it with ABC, and these are your components. When you substitute all the calculated values and simplify the final matrix, you will get something like this. So you will have sigma mi yi square plus zi square sigma minus. You'll see that some terms have minus mi xi yi, mi xi zi, and so on. Once you simplify each of the matrix, you see that they're symmetrical and similar. It's a symmetric matrix. And what we have done is we have separated all these components from omega x, omega y, and omega z. So that crossing this with this will give you your initial angular momentum matrix that we are calculating. So finally we are able to write the angular momentum of the system in terms of I omega, where I is this matrix which we have just calculated. And in this matrix, Ixx, Iyy, and Izz are the diagonal elements, and these are known as the moments of inertia. And Iyx, Ixy, Ixz, and Iyz, these are the products of inertia. And also, since it's a symmetric matrix, Iyx will be equal to Ixy, Izx will be equal to Ixz, Iyz will be equal to Izy. And this is, of course, we are assuming I discrete particles. If you assume a continuous system and you integrate, then the formula will be transformed like this: integration of y square plus z square dl. And this concludes our moment of inertia matrix.